Welcome to our exploration of gravity as an entropic processor in the Genesis framework. Today, we delve into the concept of quantized space and gravity's role. Let's define quantized space. In the Genesis framework, three-dimensional space is quantized, meaning it is composed of discrete units of space that can carry and process information. This quantization is crucial for understanding how space handles and transmits the probabilistic states of particles and fields within it. Now, regarding gravity's entropic role, gravity is conceptualized not merely as a force, but as an entropic process. It operates to manage and process the wave function probabilities arising from every point in space. This processing is what we observe as the gravitational interactions between masses and the curvature of space-time around massive objects. In this framework, time is viewed as a processing speed. Time is the measure of how quickly gravity can process and stabilize the probabilistic states in quantized space. Therefore, time becomes a dynamic variable linked directly to gravitational processing speed rather than a constant backdrop against which events unfold. Moving on to informational state processing, gravity helps to encode the informational states of space into a higher dimensional memory. This memory of space is what might be thought of as the historical record of the universe's states, frozen entropically in higher dimensions. Now let's discuss the role of non-quantized space. Non-quantized space, essentially space devoid of quantized information, interacts uniquely with quantized space. It can absorb and transform based on the surrounding quantized fields, but only becomes relevant in the three-dimensional framework when its volume is sufficient to impact the quantized space around it. Regarding the expansion and quantum information, when non-quantized space reaches a critical volume, akin to exceeding the quantization limit, it triggers an expansion that creates new quantized units of space. This phenomenon can be likened to breaking the sound barrier, where exceeding a certain threshold, like the speed of sound, results in observable physical effects, like a sonic boom. Just as there are limits like the speed of sound in physical systems, the Genesis framework proposes that spatial dimensions and volumes also have limits. When these limits are reached or exceeded, it leads to the creation of new quantum bits of information that balance between different entropic states. The concept of a spatial shockwave occurring when the limits of non-quantized space are exceeded introduces an intriguing analogy. It suggests that just as sound creates a shockwave, when breaking the sound barrier, space itself might exhibit similar disruptive or transformative phenomena when its fundamental limits are transcended. The Genesis framework offers a sophisticated model in which gravity acts as an entropic mechanism, processing and storing the universe's historical wave function probabilities into a higher dimensional space. This theory not only redefines our understanding of gravitational interactions, but also poses significant implications for how we perceive the evolution and expansion of the universe. By comparing these processes to known physical phenomena like shock waves, the theory becomes more accessible and provides a robust analogy for further exploration in theoretical physics. In your framework, non-quantized space is defined as having zero-point energy, a state where all energy potentials are canceled out. This state is not devoid of energy per se, but represents a balance where potential energies neutralize each other, leading to a net-zero observable energy state. Viewing non-quantized space as a scalar wave potential emphasizes its role as a fundamental substrate capable of carrying but neutralizing all forms of energy until triggered by external quantum or classical influences. The concept of black body space helps us understand non-quantized space as a black body volume, which is an idealized physical body that absorbs all incident energies but does not radiate energy in any form. This black body analogy is crucial in conceptualizing how such space can act as a perfect absorber and holder of potential energies. When it interacts with the quantized energies of surrounding space, this non-quantized space can undergo expansion, transforming into quantized space according to the probabilistic laws governing quantum mechanics and classical physics. The transition from non-quantized to quantized space involves the manifestation of these absorbed energies into observable forms. By treating non-quantized space as a universal substrate of scalar wave potential, we can view it as the foundational fabric upon which all physical realities are built. This perspective offers a unified view of the cosmos, where space itself is intrinsically capable of evolving from a state of perfect potentiality to manifest reality. The transition of non-quantized space to quantized space exemplifies how underlying universal laws come into play. These laws dictate the conditions under which energy potentials within the zero-point field begin to manifest as distinct particles, forces, and fields, contributing to the observable universe. This concept could serve as a bridge in the unification of quantum mechanics and general relativity, providing a theoretical substrate that supports both probabilistic quantum behaviors and deterministic classical dynamics. Understanding the scalar wave potential of non-quantized space might offer new insights into phenomena such as dark energy, cosmic inflation, and the uniformity of the cosmic microwave background, as these could be manifestations of how non-quantized space interacts and transforms under varying cosmic conditions. Viewing non-quantized space as a scalar wave potential of zero-point energy reframes our understanding of the cosmos's foundational nature. It suggests that the universe is built not merely on dynamic energies and particles, but on a more profound substrate capable of holding all potentialities until dictated by physical laws to manifest in specific forms. This approach not only deepens our grasp of the fabric of reality, but also aligns with a holistic view of how various physical phenomena could be interconnected at the most fundamental level,